Look at the first one, 1 divided by x. We tend to think that if x is positive, for example if x equals 10, then 1 divided by 10 will be less than 10. This changes, however, in the range of 0 to 1. Example, 1 divided by 0.5. Now see 1 divided by 0.5 is 2, which is greater than 0.5. Similarly, for negative numbers, we think that 1 divided by negative 2 will be greater than negative 2. But this changes in the range 0 to negative 1 because 1 divided by, let's say, negative 0.5 becomes a bigger negative number. This becomes negative 2, which is of course less than negative 0.5 itself. It is for such observations that it is important to understand that the range of negative 1 to positive 1 behaves very differently. This was the case of 1 divided by x. Let's consider x squared. Generally, for a big positive number, say 10 squared, the squared value is greater than the number itself. But see what happens in the range 0 to 1. 0.5 squared is less than 0.5 itself. Similarly, look at x cubed. 10 cubed would of course be greater than 10, but 0.5 cubed would be much smaller than 0.5 itself. In case of negative numbers, see negative 10 cubed, which is negative 1,000, is much smaller than negative 10 itself, because this is a much bigger negative number. However, in the case of the range negative 1 to 0, negative 0.5 cubed, see this becomes negative 0.125, which is much smaller a negative number compared to negative 0.5 itself. Therefore, negative 0.5 cubed is greater than negative 0.5 itself. Root x. We tend to think that if you take root of a value, say square root of 4, the value reduces. See, 2 is of course less than 4. So on taking square root of 4, the value reduced. However, think of a number such as 0.5, again in the interesting range of 0 to 1. When you take square root of this, the value does not reduce. The value increases. This would be approximately 0.7. Some very interesting observations. This range of negative 1 to 1 is very important in inequations, especially if you are plugging in values to find your answer. Do not ignore this range of negative 1 to 1. Ideally, while plugging, you should take one big negative number, something which is less than negative 1. Call it negative 1 minus. Take one value between negative 1 and 0, take one value between 0 and 1, and then take one value which is above 1. Only when you have explored all the 4 ranges should you reach a conclusion. So let's get on to learning by examples. Let's move to the next question here. Please pause the video, solve it yourself. Here are the 5 answer choices. In the always correct questions, you must look for one example for which the statement can be eliminated. For example, the first one. For a big negative value, such as x equals negative 5, you will see that 1 divided by negative 5 becomes negative 0.2, which is greater than x, which is negative 5. But x is not greater than x squared, as x squared will turn out to be a big positive number. This would be 25. So see, the condition has been contradicted, and therefore option 1 can be eliminated. Similarly, let's try eliminating option 2 as well. For a small negative value of x, say negative 0.2, see negative 0.2 is greater than 1 divided by negative 0.2, which would be a big negative number. This would be negative 5. See, this is negative 0.2. This becomes negative 5. 2x would be negative 0.4, which is not greater than x, which is negative 0.2. So this statement has also been contradicted. This can be eliminated. Look at the third one now. For a small negative number, such as negative 0.1, x is greater than 2x because 2x would be more negative, a negative 0.2. So this condition is satisfied. But 1 divided by x becomes negative 10, a big negative number, which is not greater than x. X is a smaller negative number. So even this statement has been contradicted for x equals negative 0.1. So this can also be eliminated. Look at the fourth one now. This one is the easiest to eliminate. For all negative values, say x equals negative 2. Negative 2 squared will be greater than x because negative 2 squared would be something positive. X cubed, however, will again be negative. Therefore, this can be easily contradicted. X squared is 4. X is negative 2. x cubed is negative 8, which is not greater than x squared, which is 4. Contradicted. So this can be eliminated. Look at this one now. X is greater than 1 divided by x, either for a big positive value of x, such as x equals 5, basically a value above 1. So for all such values, you will see that square of a number greater than 1 would be greater than 1 divided by a number greater than 1 because this will be less than 1, and this will always be greater than 1. So in such cases, the condition cannot be contradicted. The condition is met. And the second case, x is greater than 1 divided by x, is met when x is a small negative number, such as x equals negative 0.2. See, x would be negative 0.2. 1 divided by x will be 1 divided by negative 0.2, which becomes negative 5, which is a bigger negative number. And in such cases, x squared will be something positive, and therefore greater than 1 divided by x, which would be something negative. So even in such cases, the condition is met. These two conditions cannot be contradicted, and therefore this is always correct. E is the correct answer choice. This was relatively a lot more difficult question to get right. This was a 700+ level question. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.